Did anyone else get what I got? Cool. You got 1 more minute. You're never going to get better at doing these unless you do them on your own as well. So don't, just follow along with me and feel like you're learning stuff. You're not. That's pseudo learning. It feels like you're understanding it if you watch a teacher, but you really don't. Right, Hunter? Did he say something? No. Oh. He probably won't. I'm just kind of trolling him a bit. So the next one that we can do is number 5 because it's unit 1. Okay. So I would do number 5 if you haven't already. If you have done it already, then go work on whatever else you want to work on, or you can just check your answers with what we're doing here. It's completely up to you. This problem won't take very long. It shouldn't. So the answer for this one was C. There's a jump at 4. The limit does not agree on both sides. If you want to write that as your explanation for it, limits does not agree on both sides. Of, x equals 4, but I don't feel like writing that. Okay. The next one that you should be able to do, if you look at number 6, and it's a physics problem. So if you want, you can do it if you're one of those physics people. But we're not there yet for finding the total distance. You have to use antiderivatives for that. So we cannot do number 6 right now. Number 7, though, we definitely can do because it's a derivative problem, and that's what unit 2 is all about. So we're doing number 7 now. All right. So I broke down the layers of the derivatives here. So in red, it's that outside layer of the 5. We brought the 5 down, -1 from the power to get the 4 up there. And then I multiplied by the inner derivative of the x cubed minus cosine x, which is 3x squared plus sine x. So your answer should be E for that one. All right, onward we go. If there's questions, please interrupt. Because every time I ask, is there any questions, 99% of the time no one says anything. Okay, number 8, it says, what is the approximation of the number of liters of oil that are in the tank at t equals 15 hours? If you notice, they give you rates, like liters per hour and hours, well, they give you time as well, but they give you liters per hour. So they give you the rate, and they're looking for the number of liters. So that is the antiderivative. So that is going to be unit 4. So we don't really need to worry about that. Actually, it's going to be unit 5 because it's an application problem. So we're not going to worry about number 8. But number 9, you should be able to do. And again, I think this one was similar, if not the exact same one as we did as a warm-up before. But start working on number 9, please. Going to use the limit definition of derivative for this one. Are there any questions on 9? You should have gotten 5. The red is the limit definition. Well, the red and the orange, I guess I should say. The limit has to agree on both sides, and it has to agree exactly at that point. So that's the limit definition of derivatives. So that's what the red and orange represents. You solve the limit. It's already factored, which is weird, but AP does do that sometimes because they don't care about your algebra skills. Sometimes they just focus on the main concept of calc. So number 10, it says, what is the area of the region in the first quadrant bounded by this graph with the line x equals 2? So finding the area of a region, that's one of the things that antiderivatives allow us to do because you're accumulating change essentially. We don't need to worry about that for this unit though, because this is unit 4. We go over that. This next one, 11, is pretty complicated though, and it's going to be a unit 1 and unit 2 problem because it involves continuity, differentiability, limits, vertical asymptotes. It's crazy. This is one of those problems that's like a huge mix of concepts. Definitely should do number 11. Actually, let's do this one together because this one's kind of weird. The main thing you have to remember is that whenever you have an absolute value, it's going to be a sharp turn. So this is going to have a sharp turn at x equals 2. So I'm going to write that down. Sharp turn at x equals 2. Okay, so because of that, it's not differentiable at x equals 2, which is basically what it says right here. Okay, it still exists at x equal 2 for f, so it's continuous there. The derivative matches on both sides as well. It's the main thing is the differentiability for that one. It would not be b because it says it's differentiable and it's not. It is continuous. The limit as you approach 2, if you just plug in 2 directly, you do get 0. This one says it's not equal to 0. It actually is equal to 0. And then this one here, it says there's a vertical asymptote. Well, vertical asymptotes are non-zero over 0. There is no non-zero over 0 on this one. So the answer for this one is A. Make sense? Cool. All right, 12. We have the antiderivative symbol. That 1 to 4 means the area from 1 to 4 of this graph, essentially, between that graph and the x-axis, I should say. But either way, it's not going to be covered till unit 4, so we're not going to worry about that. Number 13 is also unit 4 because you're doing the area from 1 to 5 of this piecewise function. It's the antiderivative symbol there as well, so let's not worry about that. But number 14 is a rough problem, okay? Not exactly intuitive what rules to use. So definitely give it a minute or two. Try to figure this one out. Did anyone else get that? All right, let's go over this just for the sake of time here. So it says f of x is equal to that, g of x is equal to that, the derivative of f of g of x at 3. So first thing I did was find what the derivative of f of g of x is, which is just chain rule. That's what this is right here. Okay, well, we want to find it at x equals 3, so I just took this right here and plugged in 3 for all the x's. Okay. G of 3 can be found by using the g equation up here. So you plug in 3, you get 7. So that's where this little 7 came from. G prime of 3, well, all of g prime is equal to 3. So if you plug in 3 there, you're still going to get 3. So that's where that came from. F prime of 7, I had to put 7 into the f derivative, which is this right here. So I replaced all the x's with 7. And you get 7 over the square root of 49 minus 4 times 3, 45. The square root of 45 breaks down because there's a perfect square in there of 9. So 3 root 5, 21 over 3. Your answer is 7 over root 5. Questions on that one?
Can you go over orange again?
Sure. So this orange, right?
Yeah.
Okay, so I had to do the derivative of that f of x function, and I didn't write this down, but I probably should have. Here, let me do blue here. So what you can do is you can rewrite f of x to be this. This is what f is equal to. And it's chain rule. So to do f prime, you're taking the 1/2 and you're bringing that in front because that's the outer layer. Keep everything else the same, minus 1 from the power. So that layer is done. Now we have to do the derivative of this layer right here. And that would be 2x minus 0. So I'm just going to put a 2x in here. Cancel, cancel. And you're left with x over the square root of x squared minus 4. Because this is a negative half power, so you can put it on the bottom. Does that help?
Yeah.
All right, number 15 looks like a unit 4 type deal here. You have a bunch of antiderivative symbols. You have some derivative mixed in with that. There's always going to be one of these types of problems on every AP test that you take. So we are going to go over that, but it's unit 4, so we're not going to go over it right now. 16 is a physics problem, which we're going to cover. This one involves velocity, so we're actually going to cover this one in the next unit. So that would be a unit 3 problem, so we don't need to worry about that. 17 is, there's an antiderivative symbol right here, so we don't need to worry about that yet. 18 we should be able to do, okay, but it's also like, it's confusing for a lot of students, these limit problems sometimes. Limit definitions of derivative. But I highly advise translating this first before trying to solve it. Okay, so what this really means is, and I want you to see this pattern for these, is this is really the derivative of ln x, and then you plug in 4. That's what this means. Okay. You cannot solve that limit by using any of the techniques that we covered in class. So you have to understand that this is really just the limit definition of derivative. You can do the derivative of ln x, which is just going to be equal to 1 over x. Okay, and then you just plug in x equals 4. and you get 1/4. Excuse me. Okay, any questions on this one? Okay, 19 you can definitely do, and it's one of those like ridiculous ones where it has a lot of terms and stuff like that on it. Lots of stuff to break down. So I'll give you a couple minutes for 19. Any questions on what I got there? Remember, the goal for this, if you didn't get it, is to at least understand the why for every color change. Like, why did I set the f prime of x equal to 1/2? That sort of thing. You should know that because it says which points have a line tangent with a slope of equal to 1/2. So slope, tangent line, all that stuff represents derivative. So I did that. No questions? Okay, 20 you should be able to do as well. This one's an inverse one, so it's a little tricky. If someone can remind me toward the end too, I do want to let you know what's on the test so you know what to expect. I have a copy of it right here. I can tell you everything that's on it so you're not as shocked. You see it? Did anyone else get this? Yeah. Okay, any questions on it? Make sure you understand every single step. You don't have to do it like me, but if you have
How'd you get 6 on the bottom?
Okay, so yeah, good question. So the one thing I needed was this g of 1 right here. And then I could just plug it into the derivative, but I don't know what g of 1 is. It's not given. But I do know this yellow right here, that f of g of 1 is equal to 1 because that's the definition of inverse. If f and g are inverses, then f of g of 1 is equal to 1. F of g of 2 is equal to 2. And anything that you put in there is going to, cancel out the f and the g, and you'll get what it's equal to at the end. I also wrote it up here. I always do that. That's like my home base, as I always say. It doesn't say that in the problem, but it does say it technically because it says it right here. Let G be the inverse of F. So right away, I just wrote it to this because, I don't know, I always need it. So we're looking for we're looking for G of 1 here. So to figure that out, I wrote F of G of 1 equals 1, but I don't know what this is, but F of 0 is equal to 1. That's given in the problem. That's why I have this arrow up here. So if F of 0 is 1, that means that G of 1 has to be equal to 0. Okay, just given the fact that G of 1 is, F of 0 is 1, this 0 is G of 1. So that's how I found that. Does that make sense?
Yeah.
Okay. And then once I have G of 1 is 0, then I threw it in here. So this is the same as this right here. So then I needed to find F prime of 0. Well, F is right here. So I did the derivative of it over here, F prime of X. Then I plugged in 0. So 3 times 0 plus 1 is just 1 times 2 is 6. And that's how it's 1 over 6. I hope that makes sense. Okay, and then again, like if you have some other way of doing it because you prefer to do inverses with, how it was taught like in algebra where you switch the x's and the y's, by all means, you can do it that way. I wouldn't though, because it's more work, but people like what they're comfortable with, so I get it. 21 is unit 1 because it's horizontal asymptote, so we definitely have to do that one. All right, so we're looking for, if we plug in as x goes to infinity or negative infinity, it doesn't really matter. We'll just do infinity here, of each of these. Okay, we've done a similar problem to this before. This one, if you notice, it's going to be a constant divided by infinity. So that one's going to be 0. This one is just, or I shouldn't write equal 0, but the limit of that would be equal to 0. Let's just write it under here. A, this would be 0. For B, if you had x go to infinity for that one, you'd get infinity, so that's not the answer. For C, if you plugged in infinity, I'm sorry, over here, 1 over infinity minus 5 is going to be 0. Okay. For D, if you plugged in infinity, this is meaningless. The x's cancel, so you're left with 5 over negative 1. There's still a negative 1 on the bottom, which is going to be negative 5, which is not what we want. And the last one for E, if you get rid of this and just look at these cancel and you end up with 5. So E is the correct answer for this one. Okay, absolute mins and maxes, extrema, number 22, that's going to be unit 3, so we're not worried about that. Number 23 is a differential equation problem, that's unit 4. Actually, this is going to be unit 5 because it's a real world example. 24 is critical points. Critical points help you find relative extrema. It's going to be in unit 3, so we're not going to worry about 24. 25 is another differential equation, so that's going to be unit 4. 26 is antiderivative, and increasing, decreasing, and concavity, so that's units 3 and 4. 27 is an implicit differentiation problem, so we definitely can do this one. Start working on 27, please. It's weird they give you the derivative right away, but it's cool. Oh. Any questions on this one? All right, well, I looked through the test already, this practice test, and the only other ones that you can actually do as of right now is numbers 76 and 78. So there's only two more. Just to kind of save you time, so you don't have to hunt and look for which ones are unit 2. Let's shrink this down here. All right, intermediate value theorem, if you remember, it just means that something is there's an intermediary, there's something in between. There's a value that's between certain values if it's continuous. Okay, we've done similar problems to this before. When in doubt, I would just graph it out. So f of 2, let's just say this is 2, is 10. F of 4 is 20. And you're basically just trying to solve and figure out which one of these. So there's one here and one here, and it's continuous. Doesn't matter how you draw it, really. Never mind. There's a mean value theorem part in this. You can't do 77. I mean, you could, but you'd have to imply mean value theorem, which you could, but some of you might know that one already, but let's skip that one. 78, you definitely should be able to do, and you're definitely gonna have to do this on the test. It says there's a certain graph right there. It crosses at 1 point on the interval 1 to 0. What is the slope at this point? Okay, so we're gonna do this on the calculator, so take your calculator out. This is a calculator question. That's why it shot to number 78. So in your calculator, make sure, first of all, that you're in radians. Okay, and then in your y equals, write e to the tan x minus 2 for your y1. For your y2, put 0, because you need to know where it crosses that x-axis. We're going to find the slope at that point. Okay, now it does say it is an interval that this is on from 0 to 1. So it is important to change this on your window. Just go to x min is 0, x max is 1, and then just hit zoom 0, and then it fits it to the screen nicely. Look at that, that's beautiful. Okay, we need to find this intersection point here, and then we're also going to find the derivative at that point. So we're going to do second, calc, intersect, enter, enter, enter. Okay, so this value right here, is everyone with me still? I feel like I'm going fast, I'm sorry. Okay, that value there, we need a derivative at that value. Okay, but rather than write it down, I'm going to show you a little trick here. If you quit out of this and just type X in the home screen here, it gives you that value. So what we're going to do is we're going to store it. So to the left of number 1, hit store, and we're going to store it, and then just click alpha A. We're going to throw it in the A value. By the way, if you don't want to do this, if this is too much for you, then just write down the number. I'm just showing you a shortcut so you don't have to write all those digits down. But if you're like, what's he doing? This is so crazy. Then don't do it. Just write down the numbers and follow along with what I'm doing. All right, now from here, since X is now this A value, you can hit math 8. Okay, the derivative of, we're doing the derivative of that y1. So you could put y1 there technically, but it's not going to take that long to just rewrite it. Okay, and we're doing the derivative at that A value. So if you want, you could type the value in, or you can just hit A here and be cool. And then it gives you the answer of that. Excuse me, if you go back to here, the answer for that one would be D then. Okay. So the store button is to the left of number 1. So you hit X, that's the value that's given. I always just check it, so I put X just because if you're on this right here and you move this, don't do that, but it actually throws off the X when you go back here. Now watch. Look at that. That's terrible. Okay, but you want this value here. So I'm going to go back up here to this value because I was just kind of showing you that for fun. And then hit the store button, STO, it's to the left of number 1. And then just alpha A. I mean, you can do alpha B, you can do whatever letter you want. It doesn't really matter. I just like doing alpha A because it's closest to the alpha button. It's just easier. And then you don't have to write all those digits down. Okay, and then math 8, e to the tan x minus 2, plug that in. Okay, you do not have to actually do the derivative on this. In real life, this is how derivatives would be done. You would have a computer doing this. You don't bother, I'm going to do e to the tan x derivative by hand. Like, no one does that. Okay, maybe someone does it, but it's less than 1%. Okay, you would have a calculator or a computer do it. What, you good? Okay, so then the answer for this one would be D. Okay, you are going to see similar problems on your test.